reaction. So in our previous video we have discussed about two types of organic reactions, rearrangement and substitution. And substitution in particular is very important, okay, as I told you in the last video. Now we will be discussing about the third type of reaction, organic reaction, that is addition reaction. Addition reaction. In case of addition reaction, what is required? Unsaturation is required. Okay. So whenever you have alkene or alkyne, then in such cases, like if you have say HCl, then what happens? One of them will be bonded to this carbon atom, the other one will be bonded to this other carbon atom. As a result, now one of the bond will be gone. That means you get saturated compound in case of addition reaction. So suppose hydrogen here and security has one. So this product is the addition product that we obtain after this alkene reacts with HCl. Okay, so this is very simple, very simple. Now there are two different types of addition reaction. The first one is we have electrophilic addition reaction, and the second one is nucleophilic addition reaction. So you know what is electrophile? Electrophiles are electron loving group. That means they are deficient in what? Electron. And nucleophile, you know it, they are nucleus loving group. That means they have excess electron or negative charge. So let's discuss about electrophilic addition reaction. Number one, electrophilic addition reaction. So in such reaction, the first one that is being added is the electrophile. So let's consider this reaction. See, so you have hydrogen, so hydrogen and hydrogen. Now if you are going to react it with say HBr plus HBr, then obviously this is delta negative, more electronegative hydrogen, and this has to be delta positive. So here the first one to be added is what? Electrophile, electron loving group. So out of these two, which one is electron loving group? Obviously the one which has positive sign, delta positive. So this one is going to be acting as what? Your electrophile. So addition of H plus takes place first in this reaction. So here you can see in case of alkene, you have pi electrons over here. Now these pi electrons will approach this H plus ion. This is electrons are negative, so they will be approaching this positive charge. As a result, this bond will now break heterologically. Okay, so you get C. So since this bond is being broken, the pi bond, electrons are being involved in bond formation with this hydrogen. So this hydrogen will be attached to this carbon, or it will also be attached to this carbon. So let me write that this hydrogen is being attached to this carbon. Now here you will have a single bond. Here single bond, because this pi bond is involved in bond formation with hydrogen here. Okay, so you have single bond. Now you have hydrogen, and now the valency of this carbon is unfulfilled. Therefore, now this will have positive charge. That means carbocation will separate. Now in the second stage, since this is staying as what? Br minus. Now in the second stage, this will go and approach this carbon center and form a bond with this carbon, and you get a compound where you have addition product. So you have hydrogen and Br. Okay, so this is a simple type of addition, electrophilic addition reaction. Now let's discuss about nucleophilic addition reaction. So the second type of of addition reaction is nucleophilic addition reaction. Nucleophilic addition reaction. So here nucleophile is the one to be added to the unsaturated compound. Suppose you have compound, say C double bond, and you have hydrogen here. Now, in such cases, this oxygen is delta negative and this carbon center is what? Delta positive. So some nucleophile like Cn minus or OH minus, whenever it is present, say you have Cn minus here. Okay, this minus is what? It will have positive charge. Therefore, it is known as what? Nucleophile. Nucleophile. Cn is what? Nucleophile. Since nucleophile is going to be added to this compound, therefore it is known as what? Nucleophilic addition reaction. This nucleophile will obviously approach this carbon center. Why? Because it has positive delta positive charge. Once it approaches, both these 5 electrons will be shifting towards oxygen. As a result, there will be negative sign over oxygen. Single bond C, H, and here you will be having Cn. Now, from this reaction, in this reaction, you saw that this nucleophile is being added to this compound. Therefore, such reactions are known as what? Nucleophilic addition reaction. Now, from somewhere, if it hits hydrogen, because only this Cl minus has to be present as well, HCl or KCl. So, if you have HCl, then this H will be added in the second step to this O minus, and it will be OH, C, H, and C. So, this is the nucleophilic addition reaction. That is the second type of addition reaction. So, nucleophilic addition reaction is over. Now let's move on to the next type of reaction, that is elimination reaction. Elimination reaction. Now, elimination reaction can be compared to substitution reaction. Okay, so elimination reaction, its pathway, this elimination reaction and your substitution reaction, there is always competition between these two. Okay, if it doesn't undergo elimination reaction, then obviously that will be going substitution reaction. So you have to remember about, again, here this is the fourth type of organic reactions, and here we are going to discuss about elimination reaction. So suppose you have this compound, so CS3, CS3, and say CS3H, and this is obviously CS3 itself. Now suppose you have say BR, and you are treating with, now in this case it is alcoholic. Okay, it's not aqueous. Alcoholic KOH. Please remember, if you would have aqueous KOH, then that will undergo substitution reaction. Please remember, here since it's alcoholic, this nucleophile now will take this alpha hydrogen, this bond will break over here, and this will leave as BR minus. So here what did you find? What product will you obtain? You obtain CS3, CS3. Here you have double bond, CS2, and here this you have H2O, and KBr is the. So in this reaction, see, this is third degree alcohol, you have KOH itself. So had it been aqueous KOH, it would have undergone what? Substitution reaction. And for now, since we are discussing about elimination reaction, here instead of this aqueous, alcoholic KOH is taken. Now whenever you take alcoholic KOH, then alpha hydrogen will be abstracted. These electrons will be involved in bond formation between this carbon and this carbon, and this Br will be removed. Now in this case, you saw that you have obtained alkene from this alkyl halide. Such reactions are known as what? Elimination reactions. There are so many byproducts that is being eliminated. Water is being eliminated, KBr is being eliminated. Therefore, this is known as what? Elimination reaction. Here also, like in substitution reaction, you had SN1 and SN2. Here also you will be having E1 and E2. Okay, so let's discuss about that. And it is almost similar, but here elimination takes place. That's it. Okay. So elimination reactions are of two types: E1 and E2. E1 and number one is E1 elimination unimolecular reaction. So let's discuss about elimination unimolecular reaction. In SN1, tertiary alkyl halide was involved. Here also tertiary alkyl halide will be involved. CH3. In fact, the equation that I wrote just now is example of E1 reaction. So here let me write it again. CH3. Here you have the CH3 H, and you are reacting with K plus, and I write OH minus C. And this has to be alcoholic. This room formulation. Alcoholic. Then what will happen? This will be eliminated as water, as 2O. This will go over here, and here you have Br. This Br will be gone. As a result, you get CH3, C, CH3, double bond, CH2, water, and KBr. The mechanism of this reaction also follows the same steps. Okay? Like SN1 reaction. So in case of SN1 reaction, what was the first step? Formation of carbocation. Here also formation of carbocation will take place. Now we are going to write the mechanism how this reaction takes place. Okay? So we have CH3, C, CH3. Here we have CH3, but I'm writing it as CH2, H, and Br. So let me write it as CH3 only, because in the first step, only the formation of carbocation takes place. So I'm writing it as CH3. So in the first step, this bond will break heterobigetically, and both electrons will be taken by Br. As a result, you have carbocation CH3, C, CH3, CH3. Here you have positive charge, and Br will be staying as Br minus. Now carbocation has been generated, and I told you this is the slow state. And in the slow state, this is the rate determining state. And in this state, only the molecule of alkyl halide is involved. Only the concentration. The concentration of alcoholic KOH is not involved. Since this determines the rate of the reaction, rate determining state, and in it only the concentration of alkyl halide is involved. Therefore, it is known as one unimolecular. Okay? Now in the second step, what happens is we have CH3, C, CH3. Here we have CH3. Now CH3 I'm writing it as CH2, H, and this is carbocation. Okay, this is written as this here. Now in presence of alcoholic KOH, K plus and OH minus. Now this will abstract this hydrogen, alpha hydrogen. You have to remember this will be involving bond formation between carbon and carbon to satisfy the valency of the central carbon. As a result, we get the compound as CH3, C, CH3, double bond, CH2. And here you get water. So these are the two steps of mechanism of E1 reaction. Okay, now let's discuss about E2 reaction, that is elimination by molecular reaction. E2. In case of SN2, what was involved? Primary alkyl halide was involved. Here also primary alkyl halide will be involved in this reaction. So we have primary alkyl halide, say CS2, CBr. Now, in presence of alcoholic KOH, elimination reactions, and as a result, you will be getting CS2, double bond CS2, plus you have water and KBr. Now, mechanism of such reaction. Okay, so let's discuss mechanism. Now, such reactions takes place in just one single step. So here we have what? We have C, I'm writing with hydrogen, okay? Separately here, hydrogen, and this side also I'm writing the hydrogen separately. H, and H, and here you have Br. Now, in presence of alcoholic KOH, I'm writing K plus U and OH minus U, so that I can show you how the reaction takes place. What happens is this is already delta negative, this is delta positive. This OH minus will have strand alpha hydrogen. This is the alpha hydrogen, and this bond will be shifted here, and Br will leave as what? Br minus. So, what product do we get? We get HCH, and here we have double bond CH and H. Now this will be eliminated as what? OH and H is what? Water. H2O, and this K plus and Br minus will react to form KBr. And this reaction takes place in one single step. And since the concentration of alkyl halide as well as the concentration of KOH is involved in the single step, and this is only the reduced step, two molecules, two concentration terms are involved, therefore it is known as what? E2 reaction. And why elimination? You know it, because water molecule as well as Br is being eliminated from this particular this alkyl halide. Okay, therefore this is known as what? Elimination reaction. So let's discuss these very important types of reactions: rearrangement, substitution, this addition reactions, electrophilic reactions. So we have discussed them, and we have discussed elimination also. Now, polymerization. Let's discuss about polymerization reaction. Polymerization reaction. So you have heard about polymerization reaction. Now in such case, what will happen is there are n molecules of say A. Now these are separate molecules. Now they will be involved in formation of a long chain. That means this n number of A will be bonded together to form a long chain. And then such type of reactions are known as what? Polymerization reaction. So for example, polythene. Okay, so polythene is obtained from ethene. This is your ethene. Now whenever n number of this ethene molecule, n means more than 1000, it could be so many thousands. So n number of molecules of ethene, whenever it undergoes polymerization, and for this polymerization to take place, you need a suitable condition, that is 473 Kelvin, 1000 atmosphere, and in presence of oxygen, what will happen? This CH2 molecule will be bonded. They will be bonded among themselves to give you a very long polymeric chain, and this is known as what? Polythene. Okay, and this is the ethene. So such reactions are known as what? Polymerization reaction. So now let's discuss about condensation reaction. Condensation reactions are those reactions in which two different molecules, they come together to form one single compound. Condensation means two different molecules that are coming together to form one single compound. So the next one that we have is condensation reaction. Condensation reaction. So in condensation reaction, as I told you, two different molecules they come together to form one single compound. For example, you have CS3CH2, another molecule of CS3CH2. It will be same molecule or different molecule. In the presence of say some bases NaOH, what will happen? They will condense together to form CS3COH. COH. You have hydrogen, then you have CS2, CH4. So this compound, see, these were two different compounds. Now they have been condensed to form one single compound, and this is known as beta hydroxy aldehyde. The compound is known as beta hydroxy aldehyde. So in class 2, you have this reaction, and this reaction is aldol condensation, and the mechanism of this reaction will be taught to you in class 2. So remember, this is condensation reaction and it is aldol condensation. The last one that we have in our types of organic reaction is isomerization. So isomerization is very simple. Isomerization. So we have learned about isomerization, isomerization. Okay, very detailed. So the type of reaction where we have same molecular formula but different structures are known as what? Are known as isomers, and the phenomenon because of which they exist in such forms are known as isomerism. So here you can see this is cis-alkene, and this cis-alkene has been isomerized to trans. CS2, CS4 are in opposite sides to each other. Such reactions are known as what? Isomerization reaction, and these reactions are reversible, and you know this trans form is more stable than the cis form. I have already taught you. So please keep revising. All these reactions are very important for your exams and also for your higher classes. Thank you.